everyone, we're going to find the limit as n approaches infinity. If it doesn't exist, we're going to write does not exist and explain why. This is part 2. I started this problem on part 1 and I decided to make it into part 2 because there's a technique you can use when you see something like this, and that is dividing your highest power, which is this one. And so we're going to divide each of these terms by n squared. When I do that, it makes it a lot easier to find the limit. So I'm going to take, if I divide each of these pieces by n squared, I'm going to get 8 plus 5 over n squared, no, just 5 over n, sorry, plus 2 over n squared, divided by 3 over n squared, plus 2 over n. And if you, instead of writing all this out, we know that the denominator here, if you take the limit of this part, these are both going to be zeros. And if you take each piece of the limit here, I'm just trying to make it faster, we're going to get actually 8 plus 0 plus 0, because the limits of these are just 0, over 0 plus 0. So this is undefined, so that way that means the limit does not exist. Okay, the next one is here. We're going to do the same thing. We're going to go ahead and divide everything by my highest term, which is n squared. So I'm going to rewrite this and divide everything by n squared. And then this is going to be, no, it's going to be n cubed, sorry. Let me rewrite that. My highest is what? This one. So let's divide everything by the highest power. So that's going to be 4 over n cubed minus 3 over n squared plus 1 over n divided by 2, because that will divide out, minus 3 over n plus 5 over n cubed. And instead of writing all this out, I could do that, but let's just look at this. We know that if you have the n in the denominator, this is going to go, the bigger this n gets, this is going to go to 0. So this one's going to go to 0, this one goes to 0, and this goes to 0. This one's going to go to 0, and this one's going to go to 0. So the limit as n gets really big, we're going to have 0 plus 0, or minus actually, minus 0 plus 0 over 2 minus 0 plus 0, which is 0 over 2, which means 0. So the limit is 0. Okay? The next one, we have this one. So as n approaches infinity, 3 to the n gets really large. So it becomes increasingly large. Let's write it that way. Increasingly large. Alright? And thus the value of 1 over 3 to the n becomes smaller and smaller. Anyway, and just think about it. You put big numbers in here, the denominator is just going to get bigger and bigger. So that means the whole value is going to get smaller and smaller. So that means that the limit as n approaches infinity is going to, of n over 3 to the n equals 0. And that's just by looking at it. Okay, the next one, we have this one. And so what I'm going to do is divide everything by my highest power, which is just n to the first power. So I'm going to write that. So I'm going to have negative 2 to the n over n divided by 4 over n plus 1. I think I wrote this one down wrong. So let me, I don't think that's supposed to be there. Okay. So when you write this out, you're going to get the limit as n approaches infinity. I can rewrite this. Let me rewrite this a little bit. So when we write it as limit as n approaches infinity of negative 2 to the nth power over n times 1 over 4 over n plus 1. So if you look at this piece, it's like the previous one. This number here, if you put a huge number in there, the denominator gets really big. So it increases without bound. It has no limit. And then also you can say that this would be, this would equal 1. And this is going to be a huge numbers. So it has no limit. And you could also say that negative 2 is greater than, the absolute value of negative 2 is greater than 1. But I mean, you just can tell by, once you divided everything by n, you can tell that this number here just gets really big. So it's not going to go to a certain number. Okay, the last one we have is this one. So we're going to divide everything by n squared, because my highest power is this. So I'm going to rewrite it. So it's going to be 5n divided by n squared. 5n over n squared plus the limit as n approaches infinity of negative 1 to the n over n squared. And if I clean this up, you get limit as n approaches infinity over 5n, which is going to be 5 over n, plus this again. Negative 1 to the n over n squared. And basically we already know that this equals 0. So we get 0 plus this. Now again, if you look at this, the numerator alternates between negative 1 and 1. Okay? So as n approaches infinity, the denominator gets really big, so increasingly large. But it alternates between negative 1 and 1. Then that means that the fraction, the terms of the sequence alternate between smaller and smaller positive and negative values. So the sequence has a limit of 0. So this is going to, the limit of this whole thing, I'll just put it up here, equals 0. Okay, so you just put in big numbers here. Even though it's alternating between 1 and negative 1, it's still getting closer and closer to 0. And that's all. Thank you and have a nice day. Bye-bye.